So 5.5, we are going to start with dividing using long division, and then we will also divide using synthetic division. So we will start with long division, and then we will move to synthetic division. And those are just two ways that you can divide polynomials. It just depends on the situation. So if you recall from elementary school, you have long division. So you would write it where the larger number is under the radical and then the smaller number is out to the left. And so if you want to divide 976 by 15, you look at the first two numbers, and so 15 will go into 97 about 6 times. So when you take 6 times 15, you get 90. Then you subtract 90, bring down the 7 and the 6, and so 15 will go into 76 5 times. And so 5 times 15 is 75. Subtract, so you have a remainder of 1. So I could write this as 65 and 1/15. So it's going to be kind of the same situation where I have long division, so I'm using polynomials. It's the same kind of process. So if we want to apply it to algebraic expressions, the first number, the big number, is going to go under the radical. So I'm going to write 3x to the 4th minus 5x cubed plus, I'm going to put 0x squared plus 4x minus 6. The reason why I add this 0x squared is because you want it to go in descending order. So then I'm going to write the one that I'm dividing on the outside. So I'm going to put x squared minus 3x plus 5. So I take my first term and I look at the other first term and I match them up. So I want to see how many times does x squared, what do I multiply x squared by to get 3x to the 4th? I multiply that by 3x squared. So when I take 3x squared times x squared, I end up getting minus, so 3x to the 4th, and then I multiply it by the second term. I'm going to put this in parentheses. So 3x squared times negative 3x gives me a negative 9x cubed, and then 3x squared times a positive 5 gives me plus 15x squared. So since I am subtracting this, that means that I'm flipping this sign. So this negative right here applies to the 3x to the 4th. It also applies to the 9x, so I'm adding 9x, and then this becomes a minus 15x squared. So I'm basically flipping the sign. So since I'm subtracting, kind of like we did up here, 65 times, or 6 times 15 is a positive 90, but I'm subtracting 90. So remember that you are subtracting. So flip sign. So then I'm going to add down. So 3x to the 4th minus 3x to the 4th, that goes away. A negative 5 and a positive 9 gives me a positive 4x cubed minus 15x squared. Bring this down, plus 4x. Now I think, okay, so what is going to go from x squared to 4x cubed? It would be plus 4x. So when I take this 4x, I'm going to multiply it by x squared. So minus 4x cubed. 4x times negative 3x gives me minus 12x squared. 4x times 5 is plus 20x. Then I flip my signs, so this becomes a positive and this becomes a negative. I subtract down, so these will cancel. A negative 15 and positive 12 gives me negative 3x squared and minus 16x, and I bring down my negative 6. So then I think, okay, what is going to multiply x squared to get negative 3x squared? Minus 3. And so I multiply, I'm going to rewrite this as negative 3x squared minus 16x minus 6. I'm going to distribute this negative 3 to the x squared. So minus 3x squared. Negative 3 times a negative 3x is a positive 9x. And negative 3 times a positive 5 is minus 15. Subtract. So I'm going to flip my signs. So the negative 3, negative 3 becomes positive. I'm going to flip the sign of the negative 9 or positive 9 to become a negative 9. And then this becomes a positive 15. So this will cancel. Negative 16, negative 9 is negative 24x and a positive 9. So this answer right here, this is as far as I can factor it, or as far as I can divide. This becomes my remainder, because x squared will not go into x. You're not going to use any negative exponents. So this becomes my remainder. So my final answer, we can kind of reread this. I'm going to write it over here to the side. My final answer would be 3x squared plus 4x minus 3 minus 24x plus 9 over the stuff that I'm dividing by, so over x squared minus 3x plus 5. Okay, so we're going to try another one. I'm going to write x minus 2 first. And then I'm going to write, I'm going to give myself a little bit more room. X cubed plus 5x squared minus 7x plus 2. I don't need to put any zeros there because I have all of my exponents. So I'm going to look at my x cubed and x. How do I get from x to x cubed? I multiply it by x squared. So I take x squared and I multiply it by x minus 2. So I get x cubed minus 2x squared. And I subtract it. So this ends up going away. Minus times a minus becomes a positive. So I get 7x squared minus 7x. I bring down the 7x. Then I want to multiply, so to get from x to 7x squared, I need to multiply it by 7x. So 7x times x gives me 7x squared. 7x times a negative 2 is minus 14x. Subtract. This goes away. This becomes a positive. So negative 7, positive 14 gives me a positive 7x. And I bring the 2 down. And then I multiply, so to get from x to 7x, I multiply it by a positive 7. So then I get 7x, 7 times a negative 2 gives me negative 14. This goes away, this becomes a positive 14. So I have 16. So 16 is my remainder. So then my final answer, I'm going to use the top and I'm going to use my remainder. So my final answer would look like x squared plus 7x plus 7 plus 16 over x minus 2. So this would be my final answer. So when we have a problem like example 2, there's a shortcut method, and it's called synthetic division. Synthetic is way easier, so I'm going to write easier. My pen's not working. Easier. It only works though whenever you have an expression that is x to the first as the degree. So anytime you have x minus 2. If you look back at example 1, it was an x squared. You can't do that whenever you have an x squared. It only works as if you're just dividing by degree of 1. So the first step that you would take is you find the 0 of this x minus 2. So I'm going to say x minus 2 equals 0. So x equals a positive 2. I'm going to put that in a box out to the left. So 2 is what I'm dividing by. Then I'm going to write the coefficients of the polynomial. Do not forget the missing terms. So if it doesn't go in order, in descending order, you're going to put a 0 there. So I'm going to draw this. I'm going to end up essentially having 2 rows. So in my top row, I'm using the coefficients of each term. I'm highlighting them. This is like an invisible 1. So I'm going to write 1, positive 5, negative 7, and 2. Step number 4 is I bring down the first term. So when I drop the first term down, now I multiply 2 times 1 to give me 2. Then I add down. So 5 plus 2 gives me 7. I repeat the process again. 2 times 7 gives me a positive 14. I add negative 7, positive 14. That gives me a positive 7. Then I multiply again. 2 times 7 gives me a positive 14. My answer is 16. 16, so the last number becomes my remainder. So if you end up having a 0 in this last spot, then that would mean that your remainder is 0. In this case, 16 is my remainder, same as it was in example 2. So now I would write this as since you divided out an x, your degree is 1 less than the original. My original is x cubed, so 1 less is x squared. So I'm going to write this as 1x squared, or just x squared, either way, plus 7x plus 7 plus 16 over x minus 2. Now, is that not the same answer as we got in example 2? Not too bad. If a polynomial is divided by an x minus k, then the remainder is whatever your f of k is. So what I mean by that is, if I'm looking at here, if I look at number 3, I divided it by x minus 2, then that means that my remainder is whatever f of 2 is. That's called my remainder theorem. So if I plug in 2 everywhere that I see an x, I would get 2 cubed plus 5 times 2 squared minus 7 times 2 plus 2. If I were to simplify that, you could either put it in the calculator or you could just do it by hand. You would end up getting 8 plus 20 minus 14 plus 2. So you end up getting 8 plus 6 plus 2, which ends up being 16. So my remainder is 16. So there's 3 different ways that I could have done that. I'm going to write them out. There is long division. Long division will always work. Always. There is synthetic. And there is remainder. remainder theorem, both of these only work when your degree equals 1. So your divisor degree is equal to 1. So if 3 is a factor of f of x, then what would f of x equal? So if 3 is a factor, that would mean that you have no remainder. And so if you have no remainder, then you're going to end up getting equal to 0. So what is another name for 3? We have root 0 x-intercept. All three of these things you need to have memorized. You need to know that these are all synonymous with each other. So factor, root, x-intercept, 0. Those are all the same thing. So if it's easily divisible by your function, then your f of x is going to equal 0 because you will have no remainder. So if you have no remainder, then your f of x would equal 0. So you can divide it out and find the other factors using algebraic methods. Basically what you want to do is you want to divide out so that you get an x squared, and then you can factor. So then you can factor or use the quadratic method, the quadratic formula. So we're going to find the other zeros. It says that x plus 2 is a factor. So that means if x plus 2 equals 0, x equals negative 2. So I'm going to use synthetic division. I'm going to divide out negative 2. My coefficients would be 3, negative 4, negative 28, negative 16. So I'm going to write them out. I'm going to bring the first down, so 3. Negative 2 times 3 is negative 6. Add that down is negative 10. Negative 2 times negative 10 is a positive 20. Add that, gives me negative 8. Negative 2 times negative 8 is a positive 16. 0. So since I get 0 here, that means no remainder, which is good. It's what I want. If you don't get a 0, then you did something wrong. So then I am left with, I'm using 1 degree less than 3. So I'm going to say 3x squared minus 10x minus 8. So now I can find the other zeros. I can find the other zeros by I can either factor or quadratic formula. So once you're down to x squared, you've used synthetic division. You may have to use it multiple times, but once you've done that, then you can either just factor or use the quadratic formula. So I need two numbers that multiply to get negative 24, because I'm multiplying a times c. And I need two numbers that add to get a negative 10. So I could use negative 6 and nope, that will not work. I could use negative 12 and a positive 2. That works better. So I'm going to use the box method because that's easier for me. So I'm going to put my 3x squared in the top, minus 8, minus 12x, and a positive 2x. Then I'm going to factor up, so I can pull out a 3x in the top. I can pull out a 2, plus 2. I can take out an x and minus 4. So this becomes, if I factor it, so if I write it out, I end up getting 3x plus 2 and x minus 4. Then like we learned yesterday, we're going to set each one equal to 0. So to solve, I'm going to set each equal to 0. So 3x plus 2 equals 0. 3x equals negative 2. X equals negative 2/3. and then x minus 4 equals 0, x equals 4. So my final answers, my three solutions, are 2/3, 4, and then -2. So I'm going to write them out to the side. I have x equals -2, x equals -2/3, and x equals 4. And you could even graph this in your calculator to check your answers as well. But these would be the three that I'm looking for. Okay, we're going to do the same thing for number 6. So it says that one of my factors is 3. So I'm going to use synthetic division and solve. So 3, I have x cubed, so 1, -2, -23, and 60. I'm going to bring the first one down. So 1, you get a positive 3. -2 and 3 add to be a positive 1, 3, -20, -60, 0. This works out. So then I'm going to write my new, once I've divided, I have x squared plus x minus 20. I'm going to factor this. So two numbers that multiply to get -20 and add to get a positive 1. I have a positive 5, -4. So I'm going to write this as x plus 5, x minus 4. Set each one equal to 0. So x equals -5 and x equals a positive 4. And 3. So my final answer, it means it's going to have 3 solutions, which matches my highest degree. So I should have 3. I have x equals 3, x equals -5, and x equals a positive 4. For number 7, same thing. X minus 4 is a factor, so that means x equals a positive 4. I'm going to use synthetic division. I have a 1, a -6, a 5, and a 12. 4, add them, -2, -8, -3, -12, 0. Then I rewrite this as x squared minus 2x minus 3. I factor, so I need two numbers that multiply to get -3 and add to get -2. And so that gives me, I have a -3 and a positive 1. So x minus 3, x plus 1. So x equals a positive 3 and x equals a -1. So my three answers would be x equals 3, -1, and x equals 4. I'm going to do the same thing for part B. So I'm going to use synthetic division, divide out 4. 1, -1, -22, and 40. So 4 times 1 is 4. Get a positive 3. 4 times 3 is 12. -10, -40, 0. So that's good. You always want 0 at the end. And then I'm going to rewrite this as, I'm going to erase this right here. I'm going to rewrite this as x squared plus 3x minus 10. Need two numbers that multiply to get -10 and add to get a positive 3. So that would be a positive 5, -2. X plus 5, x minus 2. So my answer would be x equals 4, which is right here. X equals -5, and x equals a positive 2. So once you get the hang of it, it really does go pretty quickly. All right, the last one, it says f of 2 equals 0. That just means that a factor is x equals -2. So -2 is a factor. It could also be a x-intercept, a 0, which is different ways to write it. So I'm going to use synthetic division, the same steps as I did for number 7. I have -2. Coefficients 1, 2, -9, -18. Bring it down. 1, -2 times 1 is -2. 0. Negative 2 times 0 is 0. Negative 9. Negative 9 times negative 2 is a positive 18. 0 remainder. I'm going to rewrite this as x squared minus 9 because this is a 0, so there's nothing for an x. And then we can factor that. It's a difference of two squares, so x plus 3, x minus 3. And then I'm going to set each one equal to 0. So we already have x equals negative 2, x equals a negative 3, because this equals 0, and x minus 3 equals 0, so x equals a positive 3. So these would be my three answers. Same thing for part B. I'm going to use synthetic division, divide negative 2. I have a 1, an 8, a 5, and a negative 14. 1, negative 2, positive 6, negative 12, negative 7, positive 14, 0. And I'm going to write this as x squared plus 6x minus 7. I need two numbers that multiply to get negative 7 and add to get a positive 6. That would be a positive 7, negative 1, x plus 7, x minus 1. Set each one equal to 0. So x equals negative 7, x equals 1, and x equals negative 2, because we can't forget about the original.